So checking these out, we're going to roll problem by problem. Remember, column A is how do you know they're the same? Column B is how do you know they're different? So in A, I saw a little bit of this action. What property is that? Distributive property. And if you do the distributive property, does it change your answer? No, it's like simplifying kind of. So that's why that one's true. And on 5, it looks like they added 5x to one side and subtracted 5x from the other. If you do something different to both sides, do you get the same answer? No, so that's why those are not the same. Problem 2. It appears as though 2x was subtracted from both sides. Same thing, both sides. Is it true? Yes. Same thing, both sides. True. Liam, we don't need that. Okay. Over here, it looks like they intended to multiply everything by 2. But notice right here, did they multiply that by 2? No. So not the same. For problem 3, they divided everything by -3. And we got this. That's good. Everything got divided by -3. It works. On the right side, it looks like they divided everything by 6. But they forgot to divide that side by 6. So you can't just do it to one side, not the other. In order to be the same, both sides. Right here, they did a little switcheroo. That is called the commutative property. That doesn't change the answer. Over here, they added 11. Why does that not get rid of that? Why does adding 11 not get rid of the -11? Yeah, run. Well, it would be if it was like plus -11. What operation's happening right here? Well, distributive property, but what operation? Multiplication. How would we get rid of multiplication? Division. So you would need to divide both sides by -11. Not add it. Okay, so that's why that one doesn't work. And the last one, they combined some like terms. If you combine like terms, did that change your answer? Nope. But over here, they subtracted 4, which is cool. But look at these two answers then. They changed the -5x to a positive 5x, and they didn't change both sides to their opposite. So again, big idea. In order to get an equivalent equation, same thing both sides. So Noah has these two equations. You're going to notice the answers look funky. Okay? Your job, again, is to look at every step, agree or disagree with what he did, and try to make sense of his answer. All right, so let's roll through the first one. The commutative property, that kind of doesn't matter, but you can see right here, they combined like terms and got x. So we're all good till there. Would you all agree? Yes. And then I would do something different next, so I'm going to circle that and write up here. But they subtracted x and got 6 equals 1. Does that make sense? No. So usually when you get that, you say no solution. I'll show you the thing that I end up doing different is if the goal is x equals number, I subtract x from both sides. I guess I do the same thing. And get 6 equals 1. Oh, I don't do anything different. 6 equals 1. And here's where you should look, right here. If I have a number and I add 6 to it, and I have the same number and I add 1 to it, is there any way to get the same answer? No. No, they're always going to be how many apart? They're always going to be, it doesn't matter what you do. You move 1, it's 6 more and 1 more, you'll never get there. Now, so that one's good. Noah's good on that. We just have to interpret the answer to say there is no solution. Oh, okay? All right. For problem 2, we're all good until right here. But right here is where I would go different. So at 2x minus 1 equals 3x minus 1. Again, the goal is x equals number. So I need to get rid of one of these, 2x or 3x. Which one do you guys want to get rid of? 3x. You want to get rid of 3x? Oh, 2x? So if I subtract 2x from both sides, I get -1 equals x minus 1. Now look what happens. I don't end up with 2 equals 3. I end up with x equals 0, which is an answer. So you do not want to divide both sides by x here. Also, just note, if you get to that step, you could just say the answer is 0. Because if I'm multiplying two different things by the same number, what's the only way to get the same answer? 0, because anything times 0 is 0. Okay? But if right here, up at this step right here, you work on getting the variable on the same side, it'll make your equation say x equals 0. And I personally like that. Now, the biggest mistake I see there is some kid gets that. They get x equals 0 and then they'll write no solution. Is 0 no solution or is it a solution? It is a solution. It's a number. X equals 0 is cool. All right?